Hello Internet! Welcome to another episode on my channel. Today with a new topic and a project that was fun to make. I show in this episode how I built a skateboard, or better longboard. If you have the desire to build your own individual longboard, you should find a good example here. The video shows my construction, the choice of materials, the build of the template, the shaping of the wood and the assembly. Please note that this is just a demonstration how I built the board and it's not a tutorial in any way. The shown techniques have a danger of injury, therefore please take care and mind the disclaimer in the video description. If you have no experience with tools, ask friends or family members to help you. It's not that difficult to build a longboard, and for the beginning you can also do without shaping the wood too much and make the longboard without bending and using a flat surface for the board. But now let's start and let's have a short look onto my design and onto the technical drawing right here in the video. The board consists out of 4 layers of 4mm plywood. In the end, the thickness of the board will be around about 16mm. So it is quite thin. Although it is 120 cm long, it is relatively light. In order not to have too much flex and to bend down while riding, the longboard has to be bent in the opposite direction, like a bow. The additional bend in the cross direction should still provide more stability. I used the cut program for the design, but this is not necessary. The easiest way is to draw everything on a piece of wallpaper. Then you already get a feeling for the right size. For the curve of the sides you can simply use a flexible wooden strip and bend it to the desired curve and draw it. To determine the size, stand upright and take a relaxed driving position. Measure the distance between the feet of the driver and you have a good starting position for the size of the board. In our case it was around about 35 centimeters distance between the inner sides of the feet. You see the position of the feet as 2 circles on the drawing. Then you should determine the position of the axis and pay attention to have enough material and room to fix the axis to the board. I compared our construction with other boards and determined the distance of the axis to the tip and the distance to the end of the longboard. Our board has a length of 120 centimeters and the width of around about 25 centimeters. In the end, 120 cm is more than enough, in my opinion, and the board is already really big compared to classic skateboards. In the middle section, between the feet, the longboard is bent lengthwise and crosswise. For this purpose, I built a gluing template on which I pressed the individual plywood layers. We used 4mm plywood as material from an old cabinet back wall and a few pieces of birch plywood to get more thickness. I cut the birch pieces so that the grain structure of the top layer is running in the cross direction to give some additional strength in cross direction. The grain structure of the top layers of the other plywood pieces is running in longitudinal direction. I covered the plywood sheets between a layer of hardboard at the top and the bottom. The hardboard sheets will not be glued. They are there to spread the pressure more equally. Now it was time to build a gluing jig. It is more or less a template that represents the negative form of the bending profile. Once I put all the layers together, I marked the dimensions and built the template step by step. I created a drawing with Autodesk Fusion 360 and printed it out in a 1:1 scale. I cutted the single sheets and glued them together. This gave me a nice template for cutting and drilling. For the construction of the template, I measured the profile of the bend and cutted single pieces of wood to support the wood at the bended positions. Let's have a look on the template to bend the wood. There is not much to say about that template. In the end, it's the negative form of the skateboard. The idea is that the wood layers will be coated with glue and pressed onto the template. After the glue has set, the wood will more or less keep its shape. I used the construction glue for this, which is especially suitable for this purpose. To bring the single parts of the template together, I simply used hot glue. This has the advantage that parts can be removed and reused quickly. Make sure that you transfer the dimensions from the drawing on both sides equally to the template. Mark the opposite side with a carpenter square to achieve a nice parallel run of the profile in both directions. In the end, I blended the sharp edges with a wooden plane and adjusted them to the desired profile. Using the hand planner, it took me roughly 15 to 20 minutes until I blend everything down to get the profile. At the places where the profile runs out, I glued small pieces of plywood with hot glue. Then I planed the flat areas with a rapid hand plane. So even on the flat edges, this worked very good and it was easy to do. Please note that there must be a stop block in the middle to prevent too much bending, since the board should have only a slight curvature in the longitudinal direction. I made this visible in my drawing. Just have a look into the technical drawing to see where the block has to be positioned. In my case, I had forgotten the block in the middle and I had to measure it again and again, so it's really time consuming and not necessary. It's a good idea to test the gluing in dry mode without any glue and do some preparation work. For example, make sure all your tools at the workplace, your clamps at the workplace, you marked your pieces properly, you know which piece you have to put in which order and in which direction. So you have to be fast during gluing and you cannot spend too much time because depending on your environment, the glue can set very fast. We added glue on both sides of the sheets because the wood absorbs some glue and we do not want to have too little glue between the layers. Of course, you shouldn't overdo it, otherwise it can make the gluing process more difficult. I use a simple plastic spatula to spread the glue evenly. During the gluing process, everything has to go fast. Important here are the manufacturer's instructions for the glue you're using. Especially the ambient temperature and humidity can have a very strong effect. If it is very hot and a dry summer, you may only have 10 minutes to clamp everything correctly and press everything together so there is no gap between the layers. I used screw clamps for the gluing, and you need a lot of them because you need a lot of pressure to press the plywood sheets together, and the best way to achieve this is to use screw clamps. Fortunately, everything worked out well here. The layers lie neatly on top of each other and are well glued together. You can use clamps similar to the Bessie clamps with an opening of 250 mm and a clamping depth of 120 mm. You can use one clamp per 10 to 15 cm square. Ideally, there are 4 to 6 clamps with a larger span, let's say 200 mm, to clamp the middle of the model. More pressure is needed at the bends. So without clamps, the pressure is very difficult to create using other methods. Therefore, it is the easiest way to buy, borrow or rent enough clamps. By the way, a local carpenter might help you. As always, asking doesn't cost anything. After the clamps were removed, the blank of the glued layers looked pretty good, and the bending in the different directions is nice to see. I glued the paper drawing with spray glue on the blank and then started cutting. I made the cutouts on the bandsaw, but the jigsaw is just as good. wood is probably an African wood, a bit too soft and not the ideal wood for this purpose. Better would be to use birch plywood or even better maple plywood. I think this is the best choice, using maple plywood. But sometimes you have to work with that what you have right at your hand. I worked with 4 layers of plywood. As already mentioned, using stronger plywood would result in a more torsion resistant and more stable board with less flex. But more about that later. There are solutions for everything. Of course, there is the possibility to work with 1 layer of carbon fiber mats and to use epoxy glue for the gluing. But that makes the whole thing even more expensive and more difficult to work with. If you want to have the best stability with the least possible thickness of the board and the least possible weight, I recommend to go this way. But that makes the gluing more complicated and you have to learn to know how to deal with the material well beforehand. Then I drilled the holes according to the drawing to mount the axles later. Of course, I used power tools here, but you can do everything by hand. You can use a hand planer, you can use a file and sandpaper. It will just take more time. During sawing, I stayed a millimeter from the line and finally sanded the edges on the sanding machine, going straight to the line of the drawing. Yeah, and then, as always, at the end of a project, you have to sand and sand and sand and sand. Starting with the 60 grit sandpaper up to 240 grit sandpaper. Finally, I rounded the sharp edges with the router. You can use turpentine to remove the spray glue with the drawing from the board. Therefore, coat the surface evenly with turpentine using a brush. When sanding the workpiece, sand evenly and carefully and do not sand the top layer of the plywood too thin at certain points, so that you can see the underlying layer, because it will shine very bright if you paint the surface. During the painting process, 3 layers of clear varnish were applied. I picked clear varnish to paint the board. This varnish can also be used for exterior applications. In between, I let the varnish dry for several hours and sanded it with a 180 grit sandpaper. Afterwards, the top layer of the plywood pops out very nicely. As you can see here, the grain structure looks quite good. after the last coat of paint dried, I mounted the axles. I will put a link in the description to the set of axles that I used for this board. And then it was time for the first test drive. Basically, the board was already very good to ride, but the middle part was still a bit too soft and had too much flex. There were two solutions I had in mind. A narrow wooden strip, like a keel attached to the bottom, or the alternative solution, a light metal rail from a shelf support. We decided to use the metal rail, and after the next test drive we will paint it black. Finally, the board rides very well now and it's easy to steer. And we have a good template now, so there will be a sequel soon. It looks like a lot of fun. Maybe next time we try some better materials like maple plywood or carbon fiber mats glued with epoxy, but this is a story for another time. And we have a template now, so maybe there will be a sequel soon. So much to today's topic. I hope you enjoyed watching it. The technical drawings are already part of the video. If you still have questions, just let me know using the comment section below. I try my best to answer the questions. That was a lot of work, and if you want to support me, then leave a like behind. On the channel you can find all kinds of stuff about design, construction and implementations, plus various DIY projects from the workshop. This includes CAD, 3D printing, CNC, there will be more in the future, and other woodwork and metal work. So a lot of interesting topics, and if you want to join me, subscribe to my channel. That's all for today. Finally, I show you some impressions of cruising with the new longboard. Thanks for watching. See you soon. Ciao.